Dear students, it is after a gap, maybe 10 to 15 days, and I am again coming with a video. This is something from physics actually, and we are starting something with kinematics, and there is a nice concept problem that will really give you some kind of very good elaborated concept regarding some basic ideas. So at first, let me tell you something that I am giving you the concept first and then we'll illustrate the problem in detail. Just check it out. Okay, as you know that there are some kinematics equation like S equals to Vt, V equals to U plus At, S equals to Ut plus half At square, and V square equals to U square plus twice As, and Sn equals to U plus half A 2n minus 1, right? These are the basic equations within that. Now, there are whole lot of misconceptions regarding S equals to Vt. The only part is you need to remember that for every physical equation, there is one non-integral part and one integral part. That means S equals to Vt can be used if V is constant over time. If it is not so, then we need to use S equals to integral of V dt with a proper boundary where V is function of t. Same time, V equals to At can be used if A is constant over time. Otherwise, V is nothing but integral A dt. So somehow now I am trying to give you some very specific example where the misconcept really sometimes looms large in this segment. Suppose for U equals to 1 meter per second, T equals to 1 second and A equals to 1 meter per second square. What is S? So quite simple, no? S is 1 into 1 plus half into 1 into 1 square. So it is 1 plus half, that is 3 by 2, that is 1.5 meter. Now, what is S here? Most of the time, there are some kind of different answers. Somebody says S is distance travel. But let me tell you that S is not distance travel here. S is very much specifically displacement. And A is not acceleration but uniform acceleration. Now why we are emphasizing on that? Because A is uniform acceleration. So if S equals to Ut plus half At square, and then you need to find S and you are plotting the same thing. Now how can it be possible? Because these are all vectors and you are putting the value. But answer is again correct. The answer 3 by 2 is a correct answer. Now there is a whole lot of dichotomy over it, right? So that means, can we have some kind of concepts where both things converge at a single line, at a single point? Yes. That concept is A is uniform acceleration. A is uniform acceleration. That means delta V by delta T equals to constant at each and every segment, and the direction is in a straight line. That means S, V, A, these are all vectors and angle between them theta is 1, theta is 0 degree for A greater than 0. Otherwise, this is for A less than 0. That's why from the vector concept, if this vector is P and this vector is Q and the resultant is R equals to P plus Q and mod R equals to mod P plus Q, both same, or rather I can write it like this. When these two are basically equal, the only thing they are getting equal if they are all either in same direction, that is theta equals to 0 degree or theta equals to 180 degree. That means p square plus q square plus 2pq cos 0 means p plus q whole square, right? It is p plus q whole square under root, that is mod of p plus q, that is mod of p plus q. And if theta is 180 degree, where velocity vector and acceleration vector are just collinear but opposite direction, then theta is 180 degree. In that case, r equals to mod of p minus q, mod of p minus q. So here also we are having the same stuff, that u, a, s, they are all collinear in the same direction. So ut, you can imagine ut as p, half at square as q. So s, u and a are all in the same line, same direction. The angle between them theta is 0 degree. So we can use this equation without this sign. That means if they are in the straight line, vector sign hardly matters. You can put it on or you can put it off, nothing matters really. So just only for straight line motion, and that's why A becomes uniform, then only you can use this all equation. That means v equals to ut, u plus at, s equals to ut plus half at square, and v square equals to u square plus twice s. It can be useful and you can use it just like scalar value, only if and only if the motion is under in a straight line with uniform acceleration. In the next video, we are just coming with a very nice example so that you can understand the whole concept in an application mode. So stay tuned, and I hope you are just in good health. Hopefully you are liking the videos. Just try to like and subscribe as much as possible. We are coming up with this kind of much more very basic kind of thing which is known to you already, but you need to get revisited and get the concept sharper and apply it quite well in the future days. Thank you. God bless.